So in integrated math 1, I'm hoping you were familiar with problems like this, where you had to solve it. Did you do this in integrated math 1? Possibly even before then, a little bit in middle school. What is your goal in a problem like this? To get x by itself. So what would you do? You would subtract 3, and you would get x equals 2, right? That is the same idea that we're doing today. However, I don't just have plain old x. What do I have? X squared. So the first part is that I need to treat it like one of these and get x squared by itself. And then there's one other step I'm going to throw on at the end. So, is x squared by itself? Yes, x squared is the only thing on the left of the equal sign. Once I have x squared by itself, which in some of these, I'll get to where I have to actually get x squared by itself. But once I have it, how do you think you make an x squared into an x? What was that? You square root it. So what cancels out a squared? A square root. So I have to take the square root of both sides. Now, the biggest thing you need to remember when you are taking the square root is, does anyone know what I'm going to say here? You have to put a plus and a minus into the problem. But why? Let me give you a simpler problem and I'll see if that can explain it. If I have x squared equals 9, ignoring what I just said about taking the square root of both sides, what this question is saying is what number, when you square it, gives me 9 as an answer? Well, what would that answer be? 3, correct? However, there's another number that when you square it also gets you 9. Negative 3 squared also gets you 9. So there's actually 2 answers to this problem. Does that make sense? So when I go and I square root both sides, I have to talk about both the positive and the negative number that will give me that result. That's why I have to put a plus or minus in there. Now, we looked at things like this before, right? In fact, this is good review because that radicals and exponents test was the one that you just got in your grade that wasn't so hot. Well, let's review our radicals. Can I leave a radical as radical 27, or do I have to check if I can simplify it? Simplify. How do I simplify a radical? Draw a tree. What are 2 numbers that multiply to get 27? 3 and 9. And then 9 can go further. 9 is 3 and 3. So I have x equals, keep your plus or minus there in front, and then what comes out? I have a pair of 3s, so the 3 comes out. By the way, the plus or minus has to go in front of that 3. And then what stays inside? A 3. That would be my answer right there. X equals positive 3 radical 3 and x equals negative 3 radical 3. Putting this plus sign just makes it so we don't have to write 3 radical 3 twice. Okay, it's a little shorthand trick. Okay, so number 2, I don't have x this time, I have an a, but is a squared by itself? So what do? Square root both sides, remembering to put what in the problem then? Plus or minus. Am I done when I just do that? What do I need to do? Draw a tree, right? If I just plug into my calculator square root of 98, it's probably not a nice number. But I need to draw a tree. What are 2 numbers that multiply to get 98? Well, I don't know off the top of my head, but since 98 is even, it's going to be 2 times something, right? 2 times what? 49. 49 I know is 7 and 7. So, as I write my final answer, what's going to come out of the radical? The pair, the 7. And then inside I have a 2. Again, that plus or minus sign just stays out in front. Pretty easy so far? Okay. Let's look at number 3. This time I have n. Is n squared by itself yet? So what do I need to do? Divide by 6. That's going to give me n squared equals, sorry, I don't know what 426 is. I believe it's 71, but let's see. 426 divided by 6 is 71. Now is n squared by itself? So what can I do? Square root both sides, remembering to put what in the problem? Plus or minus. And yes, I'm going to ask that every single time so that you remember it and you hear it in your head as you're doing the problem. Now, can I draw a tree for 71? Why not? Because it's a prime number, isn't it? So that is as simple as it can get. Okay? The more fluent you get with these problems, the quicker they go. They really shouldn't take you all that long to do them. Okay? All right, what do I do on number 4? I have to get n squared by itself, so what should I do?
Add 2.
Add 2. Okay, so n squared is equal to 36. Now what? Square root, remembering to put what into the problem? So I have plus or minus, what? What is the square root of 36? 6. Does it still have the radical? No. I can't tell you how many people on that test that I was looking at would say that the square root of 36 is equal to, they know it's 6, but they would leave the 6 under the radical. That's a problem. Because as soon as you have 6 and 6 and you have a pair, they leave the radical. Right? Nobody's left in the radical. So you should not be having those in the radical there. Okay? All right, number 5. What should I do first? Divide by what? Negative 6. So, x squared equals, let's see, 252. 252 divided by negative 6. I get negative 42. This one's a little different. I'm going to square root both sides, remembering to put plus or minus. So I have x equals plus or minus the square root of negative 42. How do I take the square root of negative 42? You use imaginary numbers. Now, just to say this, because you never know, I don't know what you're going to encounter on a test. Sometimes they might say no solution because they don't want you to go to imaginary numbers. So if you're ever taking your SATs or taking the state testing at the end of your junior year or taking the ASVAB, any of those tests, if you get a problem and it's going to have multiple choices for answers, before you worry about imaginary numbers, look to see what the answer choices are. If none of the answer choices have an I in it, then your answer is no solution because they're not wanting you to go to the imaginary numbers. Does that make sense? I would prefer you go to the imaginary numbers for now, just because it's good practice. So that negative sign means I have x equals plus or minus I, and then let's draw that tree for 42 to see if anything else can come out. What does 42 break down into? 6 and 7, and then 3 and 2. Does anything come out? No, nothing comes out. So what am I going to call this? I radical 42. The rest of that stays inside. Okay? You won't come across very many of those. I don't know that there are any of those on your homework, but I just wanted to remind you that you do know how to deal with that. All right, you try number 6. What do I do first? Add 10. So n squared equals what? 60. Now what? Square root both sides. Remembering to put what in the problem? Plus or minus. Now I'm going to draw the tree for 60. That would be 6 and 10, right? Or you could do 4 and 15, things like that. 3 and 2, and then 5 and 2. So what comes out? A 2. And what stays inside? 3 times 5, which is 15. So my answer is n equals plus or minus 2 radical 15. So? All right. 7 and 8, trying to get tricky on you here. What should I do in number 7? Do what? Subtract 9. Can I divide by 49 first instead? No. Because 9 and 13 are like terms, you have to combine them before you can do any division or multiplication. So 49x squared equals what? 13 minus 9 is 4. And then I divide both sides by what? 49. So I have x squared is equal to 4 over 49. What do I do from there? I can't do nothing because I don't have x by itself yet. I still have x squared. So what do? Square root. So x equals, I have to remember to put what in the problem? Plus and minus. Now, the square root of a fraction seems ugly, but I'm not intimidated by this one because what's the square root of 4? And the square root of 49? That's the square root of 4 49ths, is 2 7s. Just take the square root of the top and the square root of the bottom. Okay. How about number 8? What do I need to do? Add 9. So 8n squared is equal to 743 plus 9 would be 752. Now what? Divide by 8. So n squared is equal to 94. Now what do? Square root, remembering to put in what? Plus or minus, and I'm going to draw a tree for 94. I don't happen to know two numbers that multiply to get 94, but it is even, so I know I can divide it by 2. And that becomes 2 times 47. Can I divide 47 any further? I can't. So can I take anything out? So I just have plus or minus radical 94. Questions? Hopefully it's pretty easy because most of it is just like this solving equation stuff you did in IM1. The only difference is adding that square root step at the end. Okay? All right. Happy studying.